energy.
Hi, Dad.
I am. Hi, not Miles with the cool shades. So thanks everybody who's joined and signed up. We're stretching our capabilities a little bit using some curriculum that was prepared, by the Switch Energy Alliance. I found it really interesting, and it's a subject that I'm really passionate about. I work in energy, and it's something I've been interested in since I even thought about trying to become an engineer, which I am. I have a degree in mechanical engineering, bachelor's degree. I'm not a doctor or anything. I'm just Mr. Mike, you can call me. But it's something that I can remember from my earliest memories being super interested about, why things work the way they do, and the energy that's required to make the world go round, right? So I think my passion for the subject will come through. I get really excited about it. You may have to dial me back a little bit, but I'm really interested to get your perspective and hear your questions on it too. So with that in mind, we'll let's take a dive into what is energy. Can anybody define what energy is? It's a fairly common word, but who can tell me what it is?
Well, I think there's not really any good explanation. Energy is just energy, and energy is energy. That's all I know how to explain it.
So I'd point you toward the dictionary on that one. Can anybody give me the Webster's definition of energy? There's a couple.
I can look at my iPad.
Are we allowed to look it up?
Well, I've done it for you, but I kind of wanted to hear your thoughts. Just off the top of your head, can anybody tell me what they think energy is?
Electricity.
The ability to do work.
Awesome. I heard
The
electricity,
sheer
ability
motivation to do something.
That's
like power.
It is related to power. That's right. I heard electricity. I heard ability to do work. All of those are awesome definitions and within line. I'm getting some feedback here. Who's got?
I can hear it's like you have an echo pedal.
There we go.
That was probably me. I was on mute.
So the Webster's dictionary definition of energy is the power derived from the utilization of physical or chemical resources, especially to provide light and heat or to work machines. The physics definition, like I said, there's a couple of them. The physics definition is property of matter and radiation, which is manifest as a capacity to perform work, such as causing motion or the interaction of molecules. So electricity and the ability to do work are spot on, right? It's all in the same vein. Energy has a subjective definition to it too, and I heard someone mention it when they said motivation to get up and do something. Well, if you think about where the energy you use as a person comes from, and I'm not talking about flipping on a light switch, I'm talking about moving around, getting out, playing sports, or getting up and doing your work or your chores around the house. That energy is derived from chemicals. The food you eat gets broken down inside the body and biologically gets turned into energy for your cells. That chemical and electrical energy helps you get up and move, right? And that movement allows you to do the things you do. So great definition. We're going to, as far as electricity, what do you think? Is all energy electricity?
No.
No.
It can be it can come from burned fossil fuels like coal, or it can be not chemically made, but
there's lots of different types of energy.
That's right. Well, what about is all electricity energy?
Yes.
Yes, that's right.
Testing. Yeah, it was.
Very sharp.
Good job.
So when we think about energy, and we've already said that there's many different types. The video that you would have watched in the introduction phase kind of described how broad energy is in our thinking, how in our day-to-day lives, energy's all around us, right? So with that in mind, what around you would you say uses energy?
Everything imaginable.
Practically everything.
Practically everything. Please do not draw on the screen. Thank you. That's right, everything. If you followed the video along, he does a brief description, Dr. Scott Tinker does, about how everything in our day-to-day lives require energy. And we already talked about us personally getting up and getting moving, but everything you use, everything you interact with, from the lights in your home to the refrigerator that's storing your food, to the stove or the microwave you use to cook it, it all requires energy. And if you kind of take a step back and look at the sequence of events or the sources from where the energy is used to deliver things to your front door or put that food into the grocery stores, you know, it all starts with how it's grown. It takes energy to put seeds in the ground. Industrial agriculture uses large machines, kind of like the ones you see in the cartoon picture there, to plant the volumes of food that are required to bring to the market and sell to consumers like us, so that we can have food in our homes, right? It's a modern, developed way of living. So you take
We use energy to make the things that we use energy to make things that make energy.
Also true, very true. It is a compounding of sequence, let's call it. So if we think down the road a little bit more, you know, we interface with our food supply by going to the grocery store and picking it off a shelf, right? But we already said someone's got to grow it, which takes a massive amount of energy. If you think about the number of grocery stores in the world and how farms are growing the food that fills the shelves in the grocery store, that's a lot of farms and a lot of food, a lot of energy for everyone in developed countries to have the same access to that food. But there's a step in between, right? It doesn't just, you know, go from the store, from the farm to the grocery store. It takes a distribution center, right? These, I think folks in Houston would be familiar with like an Amazon delivery or distribution center. There are 2 of them within about 10 miles of Spring, Texas. So for those of you living there in the town of Spring, you've got 2 of them within very short driving distance, which is also why you can get things delivered to your house same day service or within a few hours, right? You order it on the internet and it shows up. Well, that takes energy too, right? There's people working in those warehouses. There's vehicles and equipment moving around. There's computers and lights, heating and cooling, all of which requires energy. And all of that, the product you buy has some of that energy baked into it, right? It's the energy required to move that product from one place to another. So if you continue to think about food in a supermarket, the food would go from the distribution center to the supermarket. So before you've ever seen it or thought about purchasing it, you know, when you're picking it up and you're turning around and looking for the perfect apple out of the bunch, it's already got some energy baked into it from the process it took to get there. And then finally, you pay for it and you bring it home. So that the video used the example of a pair of jeans. Did that make sense to everybody?
Yeah.
I thought it was kind of weird to think about a pair of jeans as
That may be-
gasoline equivalent. What
Lots of
was that,
sense.
buddy?
Who, me?
Yeah, say again.
That made lots of sense to me.
Yeah. Had you
He
thought about
also
it
showed
before
his,
then? No?
car.
What is the gasoline equivalent to a pair of jeans?
Oh, I
Well,
think it was
one
like
pair of
50,
jeans-
50%.
50 for your entire closet of jeans.
49.9.
50%, I think. I lost my notes.
I mean, it
Three
was
gallons.
50 for the entire closet. That's what it was.
50
Yeah.
That's right.
What is the unit of measurement?
3
Oh,
gallons.
kilowatts.
Lots.
3 gallons.
No, that was on the questions.
Is it gallons of gasoline?
Gallons of
Gallons.
gasoline, 3.
Yeah, 50 gallons.
3 gallons.
60
Oh,
watts.
3
I told
gallons.
you it's more
3
electricity than
gallons for a
refrigeration.
single pair.
so if you buy, so your whole closet is 50 gallons. That's what you guys calculated.
Yeah.
Yes.
Well,
And your store, like the groceries you buy, is equivalent to 22 gallons of
Yeah.
energy,
Gasoline. Yeah.
gasoline.
That was the analogy they used in the video, but now you can see why that is, right? So most cars in the US and in Canada have about a 20-gallon tank for gasoline. So that's one tank of fuel, and depending on how much you pay for that fuel, it's between 50 and $100 and something, right? Well, I guess Canadians about for 20 gallons of gas, 80 some odd liters is about 135 to 150 Canadian. But now you can see when you follow this process why that is, right? Why would a pair of jeans or a grocery cart full of groceries have that equivalent amount of energy and cost associated with it, right? And it's because the energy consumption to get you that thing, that grocery cart full of groceries, starts all the way at the farm. And it takes energy to get it all the way to you. And they measure that in equivalent things. You could measure it in gallons or liters of gasoline or kilowatts or what have you.
Who orders Amazon? Whose mom orders Amazon?
Mine.
my dad orders Amazon.
So does
Fine.
mine.
And it's going to be different in Newfoundland because here, do you think it takes more gasoline to ship it all the way to the island?
Probably.
Yes.
Probably.
Or
Yeah.
diesel because there's lots
It
of
takes about a
Tankers.
movie's length time to get over here.
And I bet jeans here cost more because it's more fuel, right? To get over here.
Doesn't everything cost more in
Yeah.
Canada?
Everything
Not
costs more
necessarily.
in Canada.
No.
$130 for gas.
Canadian.
Canadian.
dollars.
Canadian.
Canadian
The
gas,
exchange
yeah.
rate.
The
We have
exchange
an
rate.
Amazon like 15 minutes from our house.
That's right.
Yeah.
Awesome. Okay. So here's a bunch of fancy numbers and colors, right? But what does it all mean? The video didn't go into this much detail, but a little bit more insight about, when you think about everybody in the world trying to gain access to the things they need and then the things they want. And we just talked about the amount of energy it takes to get those things. You could do some pretty interesting things with looking ahead in time and trying to see, well, how much energy as a population do we use now, and how much are we going to need in the future, right? And that's where companies will look at how much more energy they need to produce in order to fuel that, because as a country grows and the population grows, they consume more energy, whether it's through what were the three main categories of energy consumption from the lessons?
Electricity,
Heat.
transportation, and heat.
That's right. So those are the three basic things that we use energy for in all its forms. Those are the three basic things we use it for. some would say industry is another part of that. Like we said, making the things that will make energy. That would be part of energy, part of industry. But the three basic categories were just that: electricity, transportation, and heat. Well, it's a really big topic of conversation right now, especially within energy companies, about how the demand for energy will grow, right? We're trying to figure out what the demand will be so we make sure we can invest correctly to be able to supply it. Well, the population of the Earth right now, who knows the population roughly right of the globe right now?
8 billion.
8 billion.
8 billion?
Yeah. It's about
billion.
8. Yeah,
People
7.5
still
to 8.
say it's 7.5, but that's outdated.
7 3/4.
As of last year, it was about the best estimate, right? But yeah, we're about 8 billion people. Well, in the next 25 to 29 years, that number is going to increase by about 2 billion, right? So we'll be between 10 and 11 billion people on the planet. It's a lot of people.
I fear we're going to be overpopulated someday.
Well, there's a lot of empty land in Texas and Canada too.
We're gonna have to start living in the sea.
So what? I've been there. I don't recommend it. If the population increases, what will our energy demand do?
Increase.
Increase. You know-
Increase a lot.
Okay.
You
So
know,
where?
our planet will eventually run out of hydrogen, helium, natural gas, and oil and coal, and we'll have to, I don't know, use solar and wind only.
We'll have to go to Mars.
I can guarantee you, Miles, that that's not going to happen in our lifetimes.
We're
No.
humans. We can
Our
do
main
anything.
reason. Our main
Yeah.
reason for going to Mars will be to get more oil.
I sincerely hope not.
We're probably gonna have to use a lot of our energy to send us all up to Mars. But
That's right. It takes a lot of energy to get to Mars. If you look at the graph that's on the top right of the page, we have a snapshot in time, and we've been tracking it for a while about where the energy we use comes from, how the population is going to grow, and where that energy will come from in the future, right? I'm sure a lot of you have heard the term climate change. Some of you may have heard of the Paris Accord. If you've followed anything in the energy or climate change theme. Interesting chat there. Wouldn't the slime stuff make new oil? The slime stuff we talked about last time. I don't think I was here last
slime
time.
stuff.
Oil is made from organic matter. So if the slime you're talking about is organic matter, maybe it'll be the new oil several billion years from now.
I think they're talking about the algae we talked about last time.
Well, algae is a biofuel. We use it today for energy.
Why don't we just turn diamonds into coal so we can have more coal?
Why would we want diamonds into
I'm sorry,
coal?
that-
Isn't that
no,
like
not-
one
not-
of the most productive and hardest
Not
substances on
diamonds.
Earth?
Not diamonds into coal. Graphite into coal. We can change graphite into coal. We can have a bunch more coal.
What if we had steam engines that ran on diamonds?
Steam
That'd be a
engine
pretty
diamonds.
tough engine.
Interesting. I like your creativity. We are going to talk in a future lesson about why coal is not the fuel of the future. Okay, I'll leave it in suspense for now. But what you can kind of see that from the graph on the right, Levi. I'll point you to it. If you look at coal as a fuel, what is it doing in 2050?
It's decreasing a lot.
The demand for it is decreasing. That means there are reasons, we won't talk about them now. There are reasons why we want to get away from coal as a fuel for energy and toward something else.
Well, isn't natural gas supposed to be increasingly getting bigger and bigger?
What does the graph show you?
It doesn't look any bigger than last time. It looks maybe a little bit bigger.
Natural gas is increasing in demand because we have developed ways for it to be more economical. One, meaning cost less to produce and to supply. And two, cleaner, meaning reducing the emissions that it gives off when you burn it as for heat or for electricity production.
Oh,
So the emissions will be a topic that we'll cover in the future, but there are some of these that are more favorable because of their emission production and the types of emissions they make, and some that are not. You can see oil plateauing, even decreasing a little bit. You can see renewables and nuclear, as well as hydrogen, increasing in demand. So you can see that there's a transition of energy sources, and the energy transition is in the front of all of our minds as we work in the energy industry, because we are trying to solve the problems today that will allow us to transition to better fuel sources in the future.
How old is everyone going to be in 2050?
Let me do the math. Let me do the math here.
Middle age.
Are you going to be working? Are you going to have a job?
Let me
Gonna be
just,
working.
12.
Is this important to you guys?
I'm gonna have a job.
Oliver says
Oliver's going to be
62.
62.
Just 2050 minus 2023.
20. Yeah.
27 years, 12 plus 27. I will be 39 years old.
And
Okay.
I will be.
I'll be
I'll
a-
be 38. That's it.
I'll be a half centenarian.
So you guys will
I'll be
probably be
27.
our age.
I'll probably have a job. I'll probably
Yes.
have a job.
Hopefully you'll have a job around 40.
Oh,
It'll be our age. And so this is going to be what your where you're going to get your energy. Like when you own your own home, right? When you go to work for somebody. This is your future here. You're kind of looking at a graph of it.
And I think it's twofold, because not only will you be worried about how much energy you're consuming and therefore have to pay for with the income you make from that job, but you will also be concerned about how much energy the world has to produce to support development. Who likes Wi-Fi?
Me.
Who likes better Nintendo games?
me.
All of those require energy for future development. Computers use energy, that was covered. Everything's using energy, right? And unless we can continue to supply that energy and support the increase in population and development of countries right now that are still developing, which is the vast majority of countries in the world, energy costs will go up if we do not increase our ability or improve our ability to supply more energy. That's
Did
called
you
the energy
know-
challenge.
Did you know that China is one of the most energy consuming countries in the world?
I did.
Yes, I knew that.
Why is that?
Develop. Yeah,
Because
why
it's
is
so
it?
big.
What do you mean? The country's big? I think Russia's bigger.
China has records for the
Well,
most
yeah.
polluted air in the world.
Why would
Because the
China?
highest population.
The
Big cities.
population
It's gonna be India soon.
has more
Everything,
people.
almost everything
China's
is made
gonna,
in
like-
China.
Get tired of China. China's gonna get tired of China and move over here. Move to Russia.
What? Yeah, Russia's gonna take over China.
All
China be like
geopolitics do play a part, unfortunately. But if you had to guess, how many countries in the world out of the some odd that there are, would you say are modern or developed countries?
Oh,
Japan.
Japan is like over modern to me. Like
How
they have
many?
blue lights, people.
Their technology
How-
is
How many countries of all of them that are in the world are considered developed or modern?
UAE, United
many
Arab something.
Countries.
oh One. Okay, all I can think of is Japan.
What
Well,
about the
From your
United
perspective, do you
Like
think you live in a modern developed country?
Oh, we have a number 34.
Yes.
I
Somebody
think
said
so.
34 in the chat.
It's a good guess. I like it.
All of the countries.
Haha. How
Quite
many
the
countries are
opposite.
there now?
Oh.
I would direct you to the
Who knows how many
slide.
countries there are in the world?
There's a
Oh, we
percentage
don't-
on here.
We don't live in
Evan?
a third. I mean, I know you don't live in a third world country.
We
What-
live in a developed.
I know.
That's right. That's right. We live in a developed country if your lights are powered by electricity, if your stove is powered by electricity or natural gas or propane, if you have a roof over your head, if you have heating and cooling, air conditioning and heating, you live in a modern country. Would you believe me if I told you that 80% of the world's population, 80% of 8 billion people do not have access to those things?
Yeah.
That's
That's
That
like
wasn't
most.
convincing.
I mean, like most.
No, that was
people-
convincing. I knew that.
Okay.
Yeah, because Africa is like an entire continent. There's a lot of people who don't have that.
That's right. It is a staggering number to me that 80% of the world's population does not have ready, reliable access to electricity or heating and cooling or any of the things we enjoy on a daily basis, right? So that is part of the energy challenge. As those countries become more modernized and their populations are increasing, life expectancy goes up. It's been proven with access to reliable energy sources, with heating and cooling, with better shelter over your head. All of these amenities lead to better economic situations for countries in general, right? So access to reliable sources of energy is one of the key indicators or benchmarks for how quickly a country is developing and how far it can go. So that we'll hear more about that in later lectures as well. But to me, that's an eye-opening number that, and you should kind of ground yourself in that, is that most of the people in the world don't have reliable access to electricity, fundamentally.
Maybe I should live in a cave because all this is making me feel guilty.
It shouldn't. I can understand that, and there's some rooted, sense of shame in there. But what it does for me is it inspires me to tackle the problems today that will make those things accessible to other people, right?
It will sprout out from other countries, is
Yeah.
what you're saying.
Well, it comes from the countries that have access to those things to help other countries develop. You see the term on there, OECD or non-OECD. Those are organizations for I forgot what that term stood for. Organizations for Economic Cooperation and Development. Those are countries, and there are at least 36 of them in the world, who have signed agreements as modern countries to help others develop energy sources. Right? So there are a large number of countries outside of that who need access to energy, and then there are others in that group who have agreed to help those countries gain access to it.
Has the U.S. signed that agreement?
Yes.
Oh, hooray!
I actually just feel a little guilty. I'm not too guilty, just a little bit guilty.
Well, it's inspiring to me. I wouldn't let the guilt hang you up. It's a problem that my generation, your generation, and the generations that come after you will have to face. And if it's something that you share my passion for, there are a multitude of careers, not just in engineering or physics or mathematics, but in business, in operations, in, obviously well within inside engineering as well. But the energy challenge will affect us all. It's one of the basic human needs. So, being able to sign up for the task of tackling those challenges in the future is a noble one. All right, global energy demand. So we already said the population's growing and our need for energy is going to go up. So we're going to gain 2 billion people in the next 27 years. And the demand for energy is going to go up by how much?
15%.
70%.
15%.
Oh,
right there on the slide.
15%.
70%, 70% of that energy will be in the electricity only. Like electricity usage will go up 70% relative to where it is today. Right? Electrification is a big push, right? It's a readily accessible in most countries energy source that can be used to do cooking, to do heating, to do almost everything you need to do. Electric cars are becoming more prevalent as well, and you can't charge those without electricity, reliable electricity. Yeah.
Speaking of wires, if you go to Taiwan, you can see these like braided masses of telephone and electrical and cable wires, just mad messes. And they even bill on their own weight.
Looks disorganized, doesn't it? I wonder how more people don't get shocked by that. Here's a question for you. Do you think energy demand will go up proportionally to population increase?
Maybe, maybe not.
Possibly.
Why wouldn't it?
There could be an asteroid that hits the Earth.
There could be some
extinction
natural
event?
disaster happening everywhere.
Okay. Okay, we've covered extinction events. What else? What else would cause, if you have some countries that every time a new person is born, the energy demand in that country goes up by a certain amount, what would cause that not to be true?
People dying?
I think it's because kids will finally remember to turn off their lights.
Yeah.
No
That's-
promises.
We laugh, but that's exactly what it has to do with. Developed countries will find ways to be more energy efficient. Therefore, the energy use per person in those countries, even as the population increases, will go down. So some countries will be saving more energy, lowering their demand, while other developing countries are increasing their demand. So it'll help offset one another. What I'm trying to say there is that in the future, every person won't be using the same amount of energy. It'll balance out, and the demand won't be 1-for-1 with population growth. Okay, where does our energy come from? This was covered in the video, but I wanted to break it down a little bit more with the projection. This really just lines up between what we saw on the previous page. In today, or in 21, it was broken out just like it was in the video, where you have a few major groups. The vast majority of our energy is produced from fossil fuels. And that means burning fossil fuels to power steam turbines and generators, or some other method. That's the majority. You burn something to make steam that turns a turbine that powers a generator that makes electricity, or it's used directly for heat. You burn propane in a heater in your living room, or natural gas in the furnace that's in your attic. The other sources are, smaller portions of that. Well, in the future, it's going to shift. Like we saw on the charts, fossil fuels are going to decrease in their use to produce energy, and other sources are going to increase. And this is a snapshot in time. So technology is the driver for all of this. If we can figure out cheaper, easier ways to make electricity from other sources, those will come to the forefront and become bigger slices of this this pie chart you see here. We talked about bioenergy. Somebody mentioned algae or the slime before that y'all had talked about. Yes, an electric generator powered by an electric motor. Not great. All right, so where does your electricity come from? Let's switch gears and start talking about electricity a little bit. Where do you think, for my Newfoundland crowd, your electricity comes from?
Steam turbines.
Wind turbines, solar power, lightning, maybe.
We haven't even mentioned hydroelectricity yet.
It's on the page.
Oh.
You just answered the Newfoundland
share
question.
of energy.
Who's from Newfoundland that wants to answer that question? Anyone from Newfoundland?
What?
I'm from
Anyone
Texas.
from Newfoundland that wants to answer the question, where does our energy come from?
I'm not
Where's your
from
electricity?
Newfoundland. I'm in Newfoundland.
Hydropower. Look at the graph in the toward the right side of the page. Most of your electricity is generated from hydro. That means we're using moving water to turn turbines that are connected to electric generators, making electricity. I was shocked by this number, pun intended. The
Wow.
vast majority of Newfoundland and Labrador's electricity comes from hydroelectric. That's impressive.
Funny.
Are you so much cleaner than us?
I know, right?
What do you mean by cleaner?
Well, hydro is
Natural
definitely cleaner
gas,
than
you
natural
guys-
gas.
Less CO2 in the air.
Missions. We've got some folks that have been studying a bit.
So wait, but couldn't technically, if something happened, like a landslide and blocked your river, you just lose like half your power?
More than half.
That's 96%.
96%.
Absolutely. That's one of the risks with hydroelectric. You have to have a steady, constant flow of water to spin the turbines.
I mean, you live on an island, so
You live on a very cold island, which
Do-
means the river can freeze.
Does living on an
Well-
island translate to having a river?
Most of the hydropower
well,
door.
Mm,
I think it translates to an island covered with ocean. Next
right.
to an ocean.
Most of the time for hydroelectric to work, you have to have an elevation difference between the source of your water and your turbines. How do we usually do this? Anybody ever heard of a dam?
Yeah.
oh, I thought only beavers made those.
Like a
They
beaver
make
dam?
really good ones, but they don't generate electricity.
like a beaver dam?
Oh, like the Hoover Dam or
Oh.
Muskrat Falls.
Oh,
Anybody heard of the
Oh.
Muskrat Falls project?
I've heard of
No.
I heard of the Hoover Dam.
Sawyer has. Yeah, so one way of creating hydroelectric power, and if you look up, if you Google search the Hoover Dam, you'll see a big picture of what looks like a concrete wall in a river. If you build a dam in a river and the water can't flow from one side to the other, the water on one side gets higher and higher and higher. And then the way you let a little water through is you build these channels that come through the dam, through the turbines that spin and generate electricity, and then out the other side where it's lower.
Oh,
So
I've
you
seen one of
build that
those.
height difference into the design of the dam, and then you let just the amount of water through that you need to generate the electricity you want. So you have a constant supply of water on this side, and the downstream side of it over here, that's the outlet from the turbines. That's how hydroelectric power is created. Newfoundland just happens to have a monster supply of those rivers available.
We do have an ocean in front of us all the way over to jolly old England. So
Well, tidal hydroelectric from tidal energy is a different thing. That's taking advantage of the rising and falling tides to generate electricity, and that's a lot tougher. We may cover that in a future lesson, but tidal hydroelectric is much harder. You see wind in that Newfoundland breakdown as well. There are a lot of discussions ongoing right now about offshore floating wind turbines that will take advantage of the constant supply of wind we have here in Newfoundland to generate electricity by turning fans. Texas has the same thing. In North
23%.
Texas. What's that, Levi?
It's 23% wind.
That's right. Most of that is in North Texas in the plains, where you have higher elevation, constant wind, because there's nothing to block it. There's no trees up there taller than about 10 feet. And they have these large picturesque wind turbines sitting out there in farms. There's hundreds of them for miles. And the wind is constantly turning them so they can generate electricity.
Mr. Michael,
Yes, sir.
it's windy up there because it's so close to Oklahoma where the wind comes sweeping down the plains.
Yes, that is a fact.
That was pretty good, Miles.
Oklahoma was written way before the first wind turbine was ever built. So maybe that was their inspiration. Where else do we get the energy in Texas, or the electricity in Texas?
petroleum.
Very little solar.
Natural gas.
That's right. Very
yeah,
little solar.
We use natural gas. You guys are so much cleaner and we use water.
Nuclear gas. Yeah.
Vast
nuclear
majority
gas.
from natural gas. Where do we get natural gas?
From nature.
Where in nature?
Oh, the trees.
Try again.
Not
Well,
Miles and Emma.
the sun.
We have to drill for it. I'll give you a hint.
Oh, oil.
It comes from wells.
The
Oil.
ground. The ground.
Petroleum.
It comes from the ground. That's
Water.
right. The similar
The dirt.
reservoirs that hold oil. Yeah. Lexi, Desi, you got your hand up.
Coal, man.
Oil, coal? Which is it?
Oil, coal.
Oil, coal?
Oil, coal.
Oil.
It comes from
Oil.
wells. We have to drill wells and tap into reservoirs that are holding natural gas and produce that back to surface, where it's refined, cleaned up, and compressed. I don't know if anyone's ever heard of compressed natural gas or liquefied natural gas.
I've heard of propane.
So it's actually
Propane's
not natural gas anymore. It's natural liquid if you liquefy it.
It's called LNG, liquefied natural gas.
But shouldn't it be natural liquid since it's liquefied now?
Tomato.
Natural liquid is water.
Not necessarily. Natural gas is not a liquid
Water
at room
is
temperature. It takes a lot of energy to cool it down and compress it into liquefied natural gas, but it allows you to ship millions of tons of it around the globe on large ships.
Thought you took away energy to make something colder.
Oh
Like
no,
I said,
somebody.
we use
now
energy
Well-
to make things that produce energy.
What happens when you compress a gas? Does the temperature go down or does it go up?
Goes
Up.
It goes up. So when you compress a gas into a liquid, you increase the energy of the liquid. And the only way to keep it a liquid is to keep the pressure on it and cool it down. Because if the temperature is too high, it'll boil and turn back into gas. So you have to cool it, remove energy from it as you compress it to get it to be a liquid. All right. So where does the electricity go? Who remembers some of the statistics that the assignments threw out about how much electricity the things we use, the things we love, use?
I 100,000 watts. Or you said the average American uses 100,000 watts.
100,000 watt hours. There's an important distinction. Watt hours per day.
Hours.
That's right.
What
How
hours?
many kilowatt hours is
So
that?
what's the difference between watts and watts?
I'm glad you asked. Reviewing the assignments last night, there was a math problem in there that had you calculate whether 5 light bulbs used more energy or a hair dryer. And it told you how many watts it used.
The light bulbs used more energy. Spoilers.
Light bulbs.
So what you can see, I'm glad you asked that question. I broke it out here on the slide where you can see 100,000 watt hours is actually the equivalent of a number of watts times 24 hours in a day. That equals, and it just so happens that 100,000 divided by 24 is 4,167 roughly. So if you multiply those two together, you get 100,000 watt hours. A watt hour is just how many watts does the thing use times how many hours do you run it.
All right, thank you.
No, it's a great question and great clarification. What's cool about this is no matter where you are, your electricity usage that you pay for at your home every month is based on how many kilowatt hours you use. So that matters, right? There's an electrical meter, meaning it's measuring things on the outside of the home or the place that you're in right now, and it is measuring how much electricity is passing through it, like coming from the generation and distribution plant into your home. It's measuring how much you use, and they will send you a bill at the end of the month to pay for it.
I think
Why don't you just break the meter and you don't have to pay your bills?
so. It's really cool, actually. I think everyone should ask their parents where their electric meter is on the outside of your house. And you can actually go to the outside of your house and see the little dials moving. And you can actually see if you turn on your, I don't know, your dryer, right? Your clothes dryer, that they spin super fast, right? Or at night, whenever all the lights are off, that they're spinning really slow. And it tells you how many kilowatt hours is on there. So everyone should go outside their home and see where their meter is.
And Levi, to answer your question about why you just don't go break the meter, it's because you go to federal prison if you do.
Turn it back a little bit. Just turn it back a little bit.
That will also land you in jail.
Okay, never mind. Forget I said anything.
Jeez. Go check what other people's electric meter are.
All right, so to drive the point home a little bit, I got about 5 minutes left, and I wanted to make sure I could answer any of your questions from the assignments, if you had any, and walk through an exercise on that, kind of in the same line as which one uses more energy, light bulb versus hair dryer, but use the microwave or a microwave as an example. So first, does anyone have any questions on the assignments?
Lovely background you got there.
I don't see it. Does anybody have any
Power out of
questions?
switch
Any
cases.
questions on the assignments?
No, I did them all.
I don't. Wait, are we gonna do Kahoot?
Yep, there's a Kahoot at the end.
Wait, are we starting it now?
Nope. I'm pulling up a whiteboard because one thing I noticed in the assignment is when it came to calculating which used more energy, light bulbs, 5 light bulbs run for a certain amount of time at a given wattage, or a hair dryer, a lot of people got confused. And I want to make sure that everybody understands how to calculate that. And we are off to the
You
races.
let everybody draw.
Yep. Well, that's the point. So, okay, let's use a microwave as an example. How do we know how much energy a microwave will use? Where do we find that information?
Yeah, on the microwave, maybe.
Yeah, look on the
Sometimes it
microwave.
says
It has to say, it's actually law that any electrical device has to describe, has to state how much energy it uses. Now, it turns out we'll use an even number. An average size residential microwave, like the one you probably have in your home, will use about 1,000 watts. Okay, so let's somebody write that number on the whiteboard. I like the drawing of the microwave. Somebody write 1,000
Oh, that's me. Thank you.
watts.
it's also me.
No, no.
Collab-
no.
Emma.
Hey.
Yeah.
None of that. It's collaboration. It's not competition. 1,000 watts. Okay. Now, if we are charged for electricity by how many kilowatt hours we use, how do we figure out how much it costs to make a bag of popcorn that takes 3.5 minutes to microwave?
I see. This
Can anybody help me get there?
There we go. We found it. Working.
1,000 watts
Yep.
takes
1,000 watts an hour or a minute?
A minute.
Is it?
A second.
How many watts is it every minute though?
That's right. How many watts is it a minute? Because it takes the popcorn 3 minutes.
Yeah, 3.5 minutes. It depends on which popcorn setting you put it on.
There's a
Yeah, that's-
calculator with them.
Yeah, but microwave uses 1,000 or 1,200 watts.
Good. 1,200 is a pretty common size. I used 1,000 to be an even number. Let's start with this. How many kilowatts is in 1,000 watts?
One.
What
One.
does,
Exactly.
Oh,
because
One.
kilo means 1,000, right?
1,000.
That's right. So if a kilowatt hour is a certain number of watts times a certain number of hours, how do we figure out how much energy it takes to make the popcorn? We know the watts. We have to figure out the
The
hours.
conversion factor.
Hours, minutes, seconds,
You have
years.
to convert minutes to hours, right? So what is 3.5 minutes converted to hours?
A lot.
Is it?
3.5 minutes converted to hours.
300 minutes according to hours.
How many minutes in an hour?
Yeah.
Oh,
60.
0.5 hours.
Yeah, roundabout 0.5, or I got 0.06 hours. Okay, so we know how many hours. 3.5 minutes is 0.06 hours. And we know the number of kilowatts. That was 1, right? 1,000 watts is 1 kilowatt. So how many kilowatt hours does it take to make the bag of popcorn?
5,000.
Try again.
Oh, yeah.
5,000, it would be 500, 50 watt hours. But kilowatt hours would be 0.05 or 0.06, right? It's just 1 times the number of hours.
Is there any way for you to write that on the board here so they can
Yeah.
see it visually?
Sure.
'Cause I think everyone's getting confused with the math without seeing it.
1,000 watts equals 1 kilowatt, right?
Yes.
3.5 minutes divided by
Yeah.
60 minutes per hour equals 0.05 or 6, we'll call it, hours.
Are you writing on it?
I'm typing.
Oh, okay, because I couldn't see anything.
So 1.
Right. What do we all say?
All right, guys.
Mr. Michael?
Thank you.
What did you think? Was it interesting? Was it
Yeah,
boring?
it was. I
Was
have
it
like an
Very.
entire Google Doc full of notes.
cool? All of that material on the classroom that you joined, there's so much more available other than what I've assigned you. So if you're interested in things specifically, send us an email or send us a note, however you want to do it, and we can get you any of the extra information you want to learn about energy, right? I'm only giving you bits and pieces of it as assignments, but there's way more out there, as much as you want to learn or make a career out of one day. So
If everyone in the world made
extra
popcorn, then it would be $48,000.
I'm back.
Yeah, I do think I would want to go into more detail for this, most likely.
I can help you.
Yeah. Some more things on it. And then I found out that you can watch extra videos if you wanted to with the thing.
That's right. Feel free to explore that website. It's got a lot. I've got a little bit more access to it as a teacher account. But if there's something in particular you'd like to know more about, I'd be happy to send it to you. And that goes for anyone. So.
Mr. Michael,
Great. Yeah.
would it be possible for you to show us all the drawings that everybody did for the homework assignment thing, the visual thing?
If everyone agrees that they're okay with me sharing those to the group, we can put them together and send out a whole pack of them.
Do we have them right now where I can pull it up and see some of them if I can log into you?
You could, yeah. I've got to go. I've
Okay.
got other commitments,
Aw.
but I look forward to seeing you again at the next class. We'll start to dive more into electricity and some of the global issues we face. Thanks so much, guys. Enjoy the Kahoot, and we'll talk to you again soon.
Wait, why are you doing the Kahoot? You don't
Okay,
like them?
guys, hold on. I'm
Well,
Well,
pulling
it's
up
still
the
a work
Kahoot.
day for my dad, so
Okay.
he's
Gotta go, guys. See you next time.
Okay, bye.
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 Oh,
Oh,
fun begins.
begins.
The fun is beginning.
Okay, so here is how you do Kahoot for any of the new players.
Playa.
You just go to kahoot.it and then put in the game pin. So. All right, we're ready to start. Is anybody else need extra time to join?
No, I'm Lexi and Izzy now.
I am.
Yeah, there's 15 people, but there's only 12 participating. So,
How did we get into this? Do we just wait?
No idea.
all right. Is everyone ready to start?
Yes.
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 Okay.
Yep.
Here we go.
Who to home? But we can't do anything on this week.
Oh,
Cars.
Cars.
Blue jeans. It's blue jeans.
Makes all modern life possible.
That's
Technically,
the key
cars
to
will make
life.
modern
Blue
life
jeans.
possible. I'm gonna vote for trees.
Five.
3.
No, 5.
3.
It's 5 fingers means 5 gallons.
1 finger for each gallon.
Yeah.
I love your reasoning. Yes. I'm on the podium.
Gas is required.
1,022 gallons.
No, it's actually 5 gallons for
5
times.
gallons.
Is no, it's one
Yeah,
gallon.
it's 1
Remember
gallon.
that milk? Remember that milk you pulled off the shelf yesterday? Yeah, that was like a gallon of work and energy to get that there.
Now I'm Lexi.
So I'm
Butt
drinking a
Desi.
gallon of gas.
Right now I'm Lexi Butt Desi.
Food depends. Government.
All the answers.
It is the answer.
Bro,
is
I did all of the answers, bro.
Who's Jeffrey?
Oh my god, I got 1 wrong and I'm all the way in 8th place.
That's what happens. Dude.
Oh my god, I keep on clicking the wrong answer. I'm literally gonna blow up.
Okay.
Wait,
Oh my god. Who's monkey
actually,
number nine?
if you're gonna blow up with your head at ticking time bomb,
Who is vote for trees?
Oh, that's
Oh,
It's 25%.
it's 80%.
the
For
answer
25
is
fingers and
25%.
toes all together.
It's 80. I think it's 80.
No, it's not.
Yeah.
Yes, it is.
No,
That's 50%.
it's 25.
It's 80.
Ashwin,
Yo,
you made me get
what?
it wrong.
Wait. Ashwin, I missed one question.
That's what happens when you're Kahoot, boys.
Atmospheric emissions.
This one. Without coal.
It's from the assignment.
Yeah, I know.
It's the red one. Pick the red
Yeah,
one. It's the
yeah.
red one. It's the red one.
Love how whenever Emma gets something
Bro.
wrong, she
Yeah.
sings about it.
6th place. I'm in 6th place.
Oh, you're right behind me.
Fossil fuels produce energy by being burned and produce which of the following emissions? You know, CO2.
No. Okay, I got it right. Oh my gosh.
H2O and NO2.
Matrix.
That one was actually in one of the
Oh.
quiz.
I am
Actually,
behind
all
on
of those-
mine.
All of the ones we've already done have been on the quiz online.
Yeah, that's right. That means if you do your homework, you can ace the quiz.
Oh, I know this is like 2%. It's like
No,
5%.
it's actually 50%.
It was like 5%.
50%.
It's only 5%.
No,
Yeah.
it's fine.
Red one.
No, it's 50.
Choose the red one.
10.
It's the red one.
Everybody choose green. Everybody choose green. Choose green, guys. Don't listen to them.
Somebody chose green. I'm on the podium.
Yo, what?
Oh, thank goodness.
Whoa.
We're only in 10th question.
That's 20.
It's 20%. It's 20%.
No,
20%.
it's 5. It's 5.
And smarter.
Yeah, it's 5. It's 5.
No, smarter. Yes. Wait, no, what? Oh, yeah, it's 20. Yeah, I'm behind Monkey.
Hmm.
Am I?
Well, Watt hours of electricity do the average American use every day? 100,000 watt
3 million
hours.
watt
And,
hours.
you're saying that you're gonna
3
answer.
million watt hours?
100,000. It's
That's,
yellow.
that's a
Choose
bit
yellow.
much.
It's yellow. Choose yellow. Wait, no, wait. I'm
Why?
not.
I'm 32 points behind Lexi and Desi.
Yay, Lexi. Oh,
Which one?
Hybrid car.
A hybrid is only electricity. Combination.
I actually got
Uses
this.
batteries. You need like a AAA battery to run it.
Uses batteries.
You need a couple
Oh,
AAAs.
wait,
to run it.
Ashwin. If you didn't know, they actually have quadruple A batteries. They're smaller than triple A's.
I'm 40. Lexi and Desi, can you please get one wrong?
Who is Wish? Lola, are you Wish?
Yeah.
Sasso.
1 kilowatt.
1 million. Choose 1 million. It's 1
Yeah,
million.
it's 1 million. It's 1 million, guys. 1 million. 1
1
million.
million. No, it's 10. It's 10.
Oh no, it's yellow. Choose yellow. Yay.
No.
Ah!
Yeah. It's good. Everybody chooses red.
No
There's people
one
who
is
do-
moving. No one is moving a single spot.
That much, how many kilowatts does it use? So
Oh wait. It's.
I know this one. It
It's
was.
red.
It's green. It's green. It's green. It's green. It's green. No.
No, I think I chose
Why,
yellow.
why are you always shouting out the wrong answers?
You just gotta move the decimal
we just do a little bit of
place.
trolling.
Oh my
Oh my god.
We do a little bit of trolling.
That's what I
Yellow.
We do a little bit of
I want
trolling here
everybody
and there.
before I go to the next one. You just however many zeros it is, 1,000 watts, right? You just move the decimal place to the left that many times. Okay, so 3 times to the left.
I picked yellow instead of
That is a good trick.
Oh, typical LMO.
Oh,
Typical.
what?
I think that's a no.
Population expected to grow by 2050.
Oh wait, a gajillion.
A gallon people.
Gallon of people.
Oh, I clicked the wrong one. Oh, wow.
A
Yellow. It's yellow. It's yellow.
What
I
did I
clicked the
pick?
exact wrong one.
I'm 13 points behind Lexi and Dizzy.
I'm 1,000 points behind them.
Your growth population.
I have 8,948
Oh,
points.
50%. 15%.
Not much.
None because we'll all be saving.
By the sum of the square roots of imaginary numbers.
It's
Not
green.
very much
green.
at all.
It's green. Choose the green one. Choose the
Okay.
green
By
one.
the
The green
sum of
one's
the
right.
square roots of imaginary.
Nothing could because I.
None.
Yeah, guys, don't take a shower and save energy.
Oh, back and forth place. I'm back and forth place.
Are you Lexi with Desi?
Yes.
It's false.
It's true.
Wait, why is it showing
Swear to God, it's
China
false.
for that?
I don't know which one this is, and don't go shouting any random. Wait,
It's
yeah.
it's false. It's false. It's false.
I'm
It's
trying
false,
to say
guys.
that
It's false.
China
It's
is
false.
a developing country.
It's 100% false, guys. And everybody should know that.
I'm just gonna do the opposite of what you
Yeah,
said.
Lord.
Yay.
Oh, you're gonna do the opposite? Okay.
I
okay,
got
okay.
true. It's blue. Yay, it's blue. Got true.
Yeah.
All right, check me out. Check me out. I'm about to trick this kid.
True.
USA. Why is it so bright?
Next,
Yeah!
this is a message. Here
I give feedback.
I just feel Austin go like I just feel Austin go like
Yay, I got it right.
Whoever has the feedback.
Somebody has
can you turn off your
really
feedback,
bad
please?
feedback.
Who has the feedback? You gotta turn it off.
What's a unit? What?
it's a unit measure of heat capacity.
Heat. No, it's a measurement of work.
Yeah, it's work.
No, it's yellow. It's yellow.
Yeah, it's yellow, guys. It's yellow. No, guys. It's actually green. It's actually green. It's green. It's green.
No, I got the right one. I am behind. Wait, who's Turkey?
Who's Turkey?
All right,
You
now
would
you
have
can
thought that'd be a
unmute.
turkey.
Who's Turkey?
You can unmute, guys. If I muted you. Oh no, still. Somebody's
Miss
got a
Sarah.
feedback loop on there.
Miss Taylor, you're gonna post this video on YouTube when the
Hi.
meeting.
Hold on.
Look at her.
Let's
Am
see.
I- am I
I'm trying to
unmuted?
figure out where my feedback loop's coming from.
Am I unmuted?
Oh, yes, you can unmute. I think it was you, Miles.
Okay, here we go. A joule.
A joule is the. I'm gonna go
Rock and
with
roll.
the electrical resistance.
not me,
Electrical
not me.
Nope,
resistance.
you're right. It's not you.
There's a lot of feedback here.
Oh,
We're on the bed.
Oh. Oh.
Okay. Uh-oh.
This is what you get when you study joules.
I'm gonna.
I'm gonna figure it out. Slowly mute everyone. Let's see if I can find. I think we're off. That's good.
I am. My
Wait, tell who
crush
you're
is
muting so
slowly
that they know if you're
growing
muted.
on
choose the
my
wrong
bed.
one. Don't choose.
I-
Yay. I got the right one.
Electric. There's
The average person uses how much energy?
21.1 gigawatts of flux capacity. Wait, it's.
I don't even
It's
care
green.
anymore.
It's green. It's green.
It's
Actually,
I
88
don't
miles
even
per
care
hour.
anymore.
Actually,
Yeah,
it's
flux
green.
88 miles
capacity.
per hour.
I don't
It's green. It's green. It's green. It's green.
don't even care anymore.
It is 88 miles per hour.
Guys, I say we get one. Everybody choose the wrong answer for this
Oh
one.
my god, not this one.
Does it cost one per year? We just figured that out.
Oh my god.
This one has more time to
$10.
it.
$10.
Hold on.
$10.
263.
Let it be $10.
So this is the
has to be
60
$10.
watts. There's how many minutes are in an hour? At 10 cents
60.
a kilowatt hour.
Times.
It's so hard to speed on a math problem like this in your head.
Oh, this is an easy one.
Wait, I'm
Bruh.
behind Lexi with Desi.
Nobody got the
The
right.
Bruh.
good news
nobody
is
got it
nobody
right.
got it right. So everybody says the same.
We're still second. We're still second.
What percent of the world population?
Underdeveloped countries.
It's 25%.
50%.
It's 25%.
It's 10%.
Nope.
It's 50.
No,
it's red,
it was
it's red.
80%. Now I'm gonna get in like 100th place.
Yay! I got it right. I got it right. I got it right.
100th
W's in the
place?
chat. W's in the chat.
True, false.
And I can't
What if you
wait
say
to know more.
false?
True.
What if I said false on this one?
Wait, true.
Bro, why is Lego Man up there?
Oh, it's been ages since I've seen that dude.
No, it's Emmett.
It's been years.
If you
since I've
choose
seen
false,
the
you will
movie.
lose every point.
So I got 6th place. Part of the reason
Like
is
that
because
kind of
Kahoot
crab.
is rigged.
It's not rigged.
Future top 5 in the making.
I know. I hate how it says that. It's like, no, once it said aim for the podium next time.
Yeah, like
Second place.
What did you think
Good
I was
job,
doing?
guys.
Just aim for the podium next time.
No. It's like do better next time.
I hate Kahoot.
Hey, that's mean. That's
All
disrespectful.
right.
It's rigged. It's rigged. That's why.
That's disrespectful. Say sorry.
All right. I'm
What's the
stopping our recording.